Hello everyone. Let's continue the chapter number 6 of the foundation engineering class. We are almost at the end of this chapter. I think this time we are going to discuss these 3 points. Okay, the settlement, differential settlement of mud foundations, field settlement observation of mud foundation, and there is something we call compensated foundation, mud foundation. We will see the definition and see how to estimate how to do it. Okay, so after this we will have only this last point left, and I'm not sure if we will discuss it here yet or not. Okay, let's go for the first point. The differential settlement of math foundations. Okay, so I believe you know already what is settlement and what is differential settlement. Okay, in chapter 5, I think we discussed all type of settlement and how to estimate them. Okay, so this time we are going to see the differential settlement of mud foundation. Okay, so uh, according to the American Concrete Institute Committee, the rigidity factor KR for the foundation for mud foundation, not only for mud foundation, it can be estimated using this equation. Okay, so what is in this equation, as you can guess, E here are just elastic modulus. Okay, but for material and for soil, not let me do this. So E prime, this one, is the modulus of elasticity for the material used in the structure. So in this case, this E prime is then standing for uh, the elastic modulus of elasticity of concrete. Okay, the material, if we are discussing here concrete, the foundation is made of concrete. Okay, the mud foundation. Then ES is the modulus of elasticity now for the soil. Okay, and B, of course, you know the width of the foundation, and the moment of inertia IB of the structure by unit length of at the right angle to B. So anyway, this one mainly can be expressed as this equation. Okay. Now I think this equation is just coming from structural engineering, and this one is the flexural rigidity of the superstructure and the foundation per unit length at the right angle to B. Okay. And if we take the sum doing this one, it will be flexural rigidity. Maybe this one should not be here. Flexural rigidity of the framed member at right angle to B. Okay, this one now, this last part, okay, is flexural rigidity of the shear wall and the thickness of the shear wall, A, and H is the shear wall height. And here we have IF here, but technically if we put this one inside in here, okay, you can see here the definitions. It is like putting this inside, okay, multiplying here, multiplying here, multiplying here. That's why we keep having I E prime everywhere, okay? But it is safe. So these two equations, that put them here. If you didn't understand this yet, it is not a problem, okay? Don't worry. You will see at the end how to manage without them. So based on this, the value of this coefficient KR, the ratio delta, small delta, of differential settlement to the total settlement, there is a difference between differential settlement and the total settlement. It is not same, okay? So the ratio differential settlement to total settlement can be estimated following this way, okay? So if this coefficient Kr is larger than 0.5, then we can say that we can treat the foundation as a rigid one. So that means there will not be any differential settlement, okay? No differential settlement. So if now the coefficient, this coefficient is equal to 0.5, this one, then we say that the differential settlement is 0.1. If it is 0, then the differential settlement will be 0.35 for square math, okay? So it means B divided by L is 1. Square maths, okay? If the math is square, the shape is square. That if it is very long, it means L is larger, much larger than B, then it will be 0.5, the differential settlement. So you have three options, okay? How to estimate the differential settlement maximum. Let's go to the next point, the point number 6, the field settlement observation for math foundation. So that means we go on the field and we observe, we measure some settlement, okay? The allowable bearing capacity pressure on granular soil, if you remember in chapter 5, okay, you had this equation. And even in the previous lesson, we also talked about this equation again, okay? So this is how to estimate the ultimate capacity considering the settlement at the same time and using the n value, SPT n value, okay? So if this depth factor, FD, okay, we roughly consider it is 1, okay? We consider this is 1. Then we can say, okay, this settlement, okay, the settlement can be assumed to be like this, can be obtained from this simplified equation. In this equation, of course, you need to know the ultimate net pressure, ultimate bearing capacity, and the n value. So very simple equation to obtain the settlement. Please, this is not differential settlement, it's total settlement. Then we will try to compare the settlement obtained from this equation with observed settlement on the field. So this will be our purpose, the objective of this section, okay, to compare observed settlement with settlement obtained from this equation, okay? But remember, this equation is only for granular soil, okay? Granular soil deposit. So we have the result here.